Now this is the selective repeat case. In this diagram is indicating the procedure for selective repeat. So in this case, what is happening is now both sender and receiver are going to allocate number of buffers. Instead of sending and receiving unnecessarily, then wherever needed they can be stored in the buffers. By allocating the buffers, then it can avoid unnecessary transmissions in the network. So for that this is being used. So here both sender and receiver will allocate more number of buffers for properly sending and receiving the frames. So here, suppose in this particular example, so now sender is sending again the upper line is indicating the sender site and lower line indicating the receivers. So again the frame 0, sender is sending frame 0, receiver is receiving and acknowledging. Then without waiting for the acknowledgement, sender is sending the next frame, received, acknowledge, the next frame, so error, then keep quiet, then third frame is okay, but so instead of sending the acknowledgement of third frame, now the receiver is sending the negative acknowledgement for second because second is having error. Third okay. Then fourth also okay, received, just simply kept quiet. Fifth received, verified, if it is okay, kept quiet. So it is want to respond with the frame 2. The moment the sender gets the negative acknowledgement for frame 2, it is going to retransmit the frame 2 from the buffer, and already it has sent 5. So now it will continue from 6 onwards. Now it is going to continue from 6 onwards. Now the second frame has arrived the receiver at this point and the second frame is okay. Now at this point, instead of sending the acknowledgement for second, so the highest frame number is 5, which is received without errors. So that acknowledgement is being sent. Now at this point, the sender is getting the acknowledgement for 5, means so whatever 2 is transmitted is okay. This is also okay. Up to this are okay. Okay, that is the meaning of this. After this, getting the next acknowledgement like this. Now every subsequent frame is being successfully transmitted, successfully received. Then if you see this, within the same 17 units of time, now 15 frames are being exchanged. So send 15 plus 1. Frame 0 to 15. So total 16 frames are being transmitted by the sender in this particular case. So whereas the same 17 units time, 16 frames. So only one frame is retransmitted, that is second frame. Whereas in case of go back and from second onwards all are retransmitted, but here only the faulty frame is retransmitted, all others are transmitted only once. As a result, the performance is further improved. Now 16 frames are transmitted by the sender in 17 units of time in case of selective repeat, whereas in case of see, go back and only 10 frames are transmitted. In case of stop and wait, only 5-6 frames are transmitted. See the difference in the performance levels. So this is how the highest number of frames can be transmitted with the less time if selective repeat mechanism is being used. So that means the receiver should not reject the subsequent frames after the error frame. They should be accepted and preserved by allocating enough buffers. Now in this case, so the receiver is allocating the enough number of buffers to store them. Now what is happening is, so frame 2 is received error, so it is sending the negative acknowledgement. Frame 3 has received correctly, stored in the buffer and sending the negative acknowledgement for the frame 2 because it is error. Then frame 4 received okay, stored in the buffer. Frame 5 received okay, stored in the buffer. Now retransmission of frame 2 is happening at this. So it has received the frame 2. Now frame 2 is okay. As a result, now frame 2, 3, 4, 5, all these four frames will be handed over to the network layer at this time, because already 3, 4, 5 are processed previously, they are okay. Then the moment 2 is received and okay, so from 2 to 5 will be together, will be handed over to the network layer without any problem. That is what the receiver data link layer does to improve the performance by allocating more number of buffers required for receiving the frames from the sender without throwing them or without rejecting them because of its previous frame is faulty. Okay, so instead of rejecting, they will be accepted and stored in the buffer after processing. That means after verifying for errors. If no errors, data will be extracted and kept in the buffers. The moment correct frame is arrived, then all together will be handed over to the network layer without any problem. So this is the biggest advantage with the selective repeat protocol. Okay, so this is how in the network the data link layer of sender and receiver stations are going to communicate with each other using various protocols. Okay, so without any problems, whether the channel is noise free or noisy. So out of this, the highest performance protocol is selective repeat.